Hi there. I'm going to talk you through how you're going to do your data analysis for your project. You might want to look through this a couple of times, but hopefully this will walk you through what you need to do. So what I've done is I've combined all of the data that you sent me in the spreadsheet. So you can see there's Angela, Sarah and Isis data in there. In the spreadsheet I've sent you, there's one that's just all the data. So that's literally just copied and pasted from what you sent me. One is 2017 complete only. So what I've done here is to remove any lines where the data is incomplete, because that can make your analysis a little bit more difficult, but you'll need to make sure that you record that in your data, and then I've given you another spreadsheet in there which is 2017 results. And what I've done here is I've converted the Leica information to numbers. So 5 is strongly agree and 1 is strongly disagree. So that's what the numerical sheet is there. So you've got a spreadsheet of all of those, so you can play with that however you want to. Okay. So what I suggest you do is to do your data analysis in R, because I've sent you a spreadsheet and some code of how to do this. So if you haven't used R before, it might look a little bit intimidating to start with, but I've given you a whole load of documentation. So what you need to do, so just on a university computer, if you just look for R, it might be R x64, something like that, but university computers all got R installed on them. So when you open R, you'll get something that looks like this. Okay. Then what you want to do is to go to File and then Open Script. Okay, and then you can open the script that I've sent you. So if I just find that there, so you can see here's my script file. So if you have a look at this script file, this contains all of the basic stuff that you need to do, and it includes some explanations of things. So just to explain this, so anything where there's a hash in the beginning, that's not a line of actual code, that's a comment from me, so that's explaining what's going on. Okay, whereas a line like this, where there's no hash, that's an actual command that gets R to do something. Okay, so you can see there's more documentation in here than there is actual code. Okay, so the way to run code in R is for a particular line. So here's the first line of code that I'm going to use. Okay, and this is going to import my data file. So you can see I've annotated it throughout. So part one is we're going to open the file and we're going to check that it's imported. Okay, so if I put my cursor here and then I click Control R on the keyboard, then that executes the command. So I'll just get rid of that again. Okay, so just Control R executes the command, and what this command is going to do is it's saying we want to find a data file. Let's just see. So we want to find we want to read a data file, so .csv file, and this one says open a window to choose the file and import that and call the whole thing data. Okay, so if I do that again. Okay, now I can go and find that file. So wherever you've saved it on your desktop, so there's the file that we need. So we now see that it's done that. So what it should have done is to import the data, but we need to check that that's worked. Okay, so the next thing I'm asking it to do is to tell me the names of each column in the data set to check it's imported properly. So if I again click Control and R together, then you can see it's given me a list of all of the different columns in the data set. So we start with the ID number, then who entered the data, so on and so forth. So we've got all of the different columns in the data set, so we know that it's imported the data set there. And if we want to, we can then just check the structure of that data set so we can get a bit more information. So we can see that so if we look at this year of study, okay, we can see it's a factor, so it's a category variable, and we can see we've got there's 2 levels, so all the data says either it's first year or it's foundation year. Okay, whereas here we've got subject area, so it says we've got 10 different levels here, so it gives us all the various different options, whereas A1 is that question, so there it's got numerical information, so that's quite useful for just seeing how much we've got. And we've got 123 objects in the data sets. There's 123 students that we've got data from overall. Okay, so that gives you some basic information about the data. So, but what we then want to do is to get some descriptive statistics from the data. So the first thing we need to do is to define the median. So we're using Likert data, so we're only gone at a scale from 1 to 5, so we can't really do means quite in that way. So what I suggest that we do is to use medians. Okay, so the first thing we need to do is to find out what the median is. So what I've done in the data set, so if you look back at the spreadsheet, you've got the individual questions there, and you've got a list of which question is which in terms of the coding. But then if we go to the end of the spreadsheet, what I've done is to create an average of all of the questions that relate to autonomy or independent learning, all of the ones that relate to communication, all of the ones that result in subject skills. So that's an average of 10 different questions, and then we've got an overall self-efficacy score, which is an average of all 50 questions. So we can separate out the 5 different domains and get a total estimate of self-efficacy. Okay. So what I might want to do to start with is to think about the autonomy or the independent learning domain. So let me just put that in there. What I want to do is to get a summary of the data set, but I don't want the whole data set, I want just the autonomy data. So the way that we do this, so we say summary of data, so that's telling it which data set to use, and then then we put a $sign in, and then we say autonomy. So I only want a summary of that autonomy column. I don't, there's 77 different columns in there, I only want to do that one. So if I click Control and R there, then it gives me a summary. So I can now see I've got the minimum value, I've got the maximum value, median, and I've got my interquartile range, which is the difference between the first quartile and the third quartile. So that's quite useful. So I can now start to put that in my results section. So I've given you examples throughout of how to report that. So we have the median, and we're reporting the interquartile range. Okay. But that's for everybody, and for your individual projects you'll want to be doing this by different factors of interest. Okay, so what I'd like to do in this case is I'm going to look at the difference between those who are first year students and those who are foundation year students. Okay, so what I'm going to do here is I've got a function called tapply, so I'm asking it to look at data autonomy, so that's there before, and then I want to tell it, well, what I want to separate it into categories, so I want to separate it by year of study. Okay, so it's data, then the $sign, separate it by year of study, and then I want it to report the median. So again, press Control R, so you can now see it's given me the median of each of those, so you can see actually they're the same, and then I can do the quartiles, so it's now doing that by quantile. So we can now see the lower range that we'd report would be 3.7, and the upper quartile range would be 4.1. Okay, so you can now put that into your results section, and again I've given you an example there. Okay, so you'll obviously need to replace whatever you're interested in, so it might be communication in there and it might be gender in there. Okay, so you'll need to adapt this code to answer the questions you particularly want to. Okay, so we've now got a comparison of the Likert scores, but what we now want to do is a statistical test to see whether they're any different. Okay, so we're going to use Kruskal-Wallis test because we've got non-parametric data. So the function for Kruskal-Wallis test is there. So again, I've got data, the autonomy data, and then I want to analyse that by year of study. Okay, so this is the whole data set, and then this is the way I want to divide it up. Okay, so again, Control R, then that gives me a statistical test. So we've got the Kruskal-Wallis, and it gives me the test statistic, the number of degrees of freedom, and the probability. And you need all 3 of those to report in your results section. And again, I've given you an example of how to do that in the code. Okay, so that will help you write with your results section, but then we want to draw a graph of it so that we've got some figures in our report. So the basic function that we're going to use is a box plot. So if I just do this, so again we've got data autonomy, and I want to divide that up. Notice we've got a slightly different symbol, not slightly different format here, by year of study. Okay, so if I run this particular piece of code, okay, that's the graph that I get, okay, which there's nothing wrong with that graph per se, but we could do a lot better than this. We haven't got an axis label. I think this is quite ugly. We haven't got, there's no title and whatever. Okay, so what I've done is to set you up a function for drawing graphs. So if you don't want to go through all of this, then don't worry about it. But what I've done is to make it so that you can set up some nice graphs. So to just briefly go through this, what it's going to do is what we're going to do is to generate a graph that puts the Kruskal-Wallis statistics on there and draws a slightly nicer looking graph than this. Okay, so what I would do now is to highlight all of that. Okay. And to highlight this bit in here. Okay, so what we're doing is to say, rather than just doing the standard box plot, we've defined a specialist graph which I've called just Likert graph. Okay, so if I've highlighted all of that and I now click R, then you can see we've got a slightly nicer graph. Okay, so I've put a title on here. It's got the Kruskal-Wallis values that we got from before, and because we've got the different domains, it's highlighted that there. So that's a nicer graph. You can scale that if you want to. So it's a little bit big at the moment. So if you can, you can do that. That's not a problem. Okay, so you might want to just put that into your report, but what you might want to do is something a bit more sophisticated, is to actually show all of the different domains and the total altogether. So I've given you the code to do this. So here you can see, so this one is doing autonomy by year of study. Okay, but then the second graph is going to do the communication by year of study. And what was this command here says to set up a graph, a grid of 6 graphs. So if I highlight all of that and click R, then, and that's obviously a little bit small, but I can expand that out. Okay, so now let's get something that looks nice, sort of about there. Now I've got all of those 6 different things. So I've got each of the 5 domains and I've got the overall self-efficacy, and it's automatically done the statistical analysis for us on each of them. It's labelled the figures correctly, so that's a really nice way of showing the data. So if you you'll want to change that, so you want to substitute in whichever domains you're doing and whichever dimension you're looking at in there. And make sure you change the titles if you need to. You can change the colours if you want to, so they're just specified there. So you can customise that if you want to, but if you just want to put your own data in, then that's fine. Okay. So then all you need to do is to copy that graph. So the easiest thing to do is if you copy it as a meta file, so right click, copy as meta file. Then you go into Word, then if you just do paste, then you've got a nice looking figure in your report. Okay, so I've sent you a Word document with a copy of that, which includes how to report your statistical methods in there, a figure, an example figure legend, and what you should be writing in the text of your results. So hopefully that will help you to put that together. So I've done this for year of study, but you've all got your separate hypotheses. So what you want to do is to first of all have a look at the spreadsheet. Now for some of you it's going to be easier than others. Some of you are doing just doing gender, but some of you wanted to look at the level of experience you'd had before. So be thinking about a way of getting this data into some sort of category data. So you might want to work out a way of if we're looking at how often people did particular tasks at school, so we might want to divide them into high, medium or low levels of experience to do our statistical analysis with. Okay, so you can adapt this code as you want. What I suggest you do is to save a copy and then save a second copy, and you edit that second copy so you've always got a copy that works, but hopefully that will allow you to start getting going with your data analysis.